Hello everyone, welcome back to TIN 205 Industrial Statistics 1 with me, Ferry Afrinaldi. On this video, we will start chapter 2, which is the descriptive statistics. And this will be the contents of chapter 2. So basically, we will discuss three things. Number one is the pictorial and tabular method of describing data. Number two is the measures of location of a set of data, and then the measures of the variability of a set of data. So I think I described this, or I explained this in the previous video, the meaning of the descriptive statistics. So descriptive statistics is statistics that describe or summarize a set of data using visual techniques and numerical summary. So three things that we can use in order to three things that we can use in descriptive statistics or in describing the data. Number one, we can use picture, we can use tables, and we can use numbers. And the numbers means the numerical summary. So the visual techniques consist of two, the pictures and the table. And sometimes the table also a numerical summary. We can say that a table is a numerical summary also. And the last one is the numerical summary. What I mean with the numerical summary is that if you remember in your high school, you are calculating for the average, median, mode, range, and so on and so forth. They are numerical summary. So based on the summary of the data, based on the picture that we draw based on the data, we try to get some information based on the data, and based on that information we're gonna make a decision. That's the objective of descriptive statistics. So we try to get information from data, and based on the information that we get from the data, we will make a decision. So I'm gonna start with the first one, which is the pictorial and tabular methods of describing data. So I will give you some notation first. The small n here, it labels the sample size. The sample size means the number of observation in a single sample. Okay, and remember, a sample is a subset of a population. So I'm gonna give you an example. Okay, so so n equal 4. So that's mean the sample size is 4. So that means there are 4 observations in the sample. So let's say that X is the sample, and we have 40, 41, 44, and 50. Okay, so this is the notation for sample. So this is 40 is the first observation in the sample, 41 is the second observation in the sample, 44 is the third observation in the sample, and 50 is the last observation in the sample. Okay, and the sample size is 4 because there are 4 observations in the sample: 1, 2, 3, and 4. So the small n, it labels the sample size. So n equal 4, that means the sample size is 4. And remember, if we use capital N, the capital N is the label for the population size. Okay. Now I'm gonna coming back to the notation. So the observation in the sample we label is as x. So x sub 1, that is the first observation, x sub 2, it is the second observation, and x sub 3, that is the third observation, and x sub n, it is the n observation in the sample. So here, let me see, where is it? Okay, here in this sample, so our x sub 1 is 40, x sub 2 is 41, x sub 2 is 44, and x3 is 50. Okay, so in general xn, so x sub n, it is the nth observation in the sample. Okay, so that's how we write a sample mathematically. So this is the notation for the sample and sample size. Okay, the first technique that we will use in order to describe data is the dot plots. So the dot plots, it is a very simple technique in order to summarize a data. So, and remember, the dot plots, they are good when you have a small sample size. When you have a big sample size, it is not a good idea in using the dot plot. And based on the dot plot, you can see the distribution of the data. It is very easy by using a dot plot to see the distribution of the data. So as its name indicates, we're gonna use dot in order to represent an observation. So one observation is represented by a dot, and then when an observation occurs more than once, then there will be more than one dot for that observations, and the dots are stacked vertically. Okay, that is the dot plots. I'm gonna give you a simple example of how to make a dot plot. So assume that, see, in the Excel here, so we have a sample of, let's say that it is what? It is the number of defective products, okay, number of defective products in 14 days. Okay, so this is the number of defective product in day 1, this is the number of defective product in day 2, and this one is the number of defective products in day 3. So in total we have 14 observation. And then based on this observation, we're gonna draw a dot plot. Okay, so I'm gonna copy and paste. I think I'm just gonna put it here. So those are our observation, and see, based on this, the minimum value is 1 and the maximum value is 10. So this is the mean, So our data is from 1 to 10. The first thing that we need to do is, in order to make a dot plot, we need to draw a line, and then we put a number in that line: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. Okay, so I think this is what we need. Okay, so we have 1 here, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, and we need to label this. So the line represent what? So number of defective products. Okay. Okay. Okay, see, number 1 appear once, so we just put a dot, but I don't think that I can make a dot, so I will just use X. Okay, let's see, so this is an X, so number 1 appear once, and there is no number 2, so we have no number 2. Number 3, we have 2 of them, so we have 2 number 3. So I have number 3. Okay, and there are 2 of them. Number 5, I have 1, 2, 3, 4, 5. 5 of them. Number 5, 1, 2, 3, 4, and 5. Okay, I don't have number 4, but I don't have number 6, but I have number 7, 3 of them. Okay, 1, 2, and 3. I have 2 number 9, there is no number 8. 2 number 9. And I have 1 number 10. So this is the dot plot for the sample, and here our sample size, the small n, is 14. Okay. Okay. So from the dot plot, we can say that the data is symmetric. Symmetrical means most of the data are in the center. Most of the data is in the center. Okay, see that most of the data in our dot plots is they are at the center, so we can say that they are symmetrical. So if we draw the distribution of the data, so the distribution of the data gonna be something like this. Okay, okay, so this is symmetrical. Okay, but there are 2 other shape of the distribution of the data. So sometimes when you draw a dot plot, you're gonna find something like this. I'm just gonna take the line and the number. Okay. Okay. So before I forget, so this one is symmetrical. It is about symmetrical. It is not exactly symmetrical, but it is, we can say that it is symmetrical. But sometimes when you draw the dot plot, you're gonna get something like this. Maybe you're gonna get something like, oops, you're gonna get something like this. Okay. 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 I'm gonna add some more here, and then I'm gonna add, okay, 4 of them over here, and then I'm gonna put 2 here, and okay, I'm gonna add, okay, and here, and this one. Okay, something like this. So if we draw the distribution of the data, it's gonna be something like this. Okay. 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 So it is very clear here. It is very clear here that that this picture, it is not symmetrical. Not symmetrical. So the data is skewed. Okay. Okay. And with this kind of shape, we can say that it is skewed to the right. Okay. When you have some data, and if it is like this, sorry, it is something like this. Okay, so it is the opposite of this one, and we call this as the skew. The data is skewed. The data is skewed to the left. Okay, so basically there are 3 types of data distribution that we can see from a dot plot, but actually it is not just from a dot plot. We can also see it from other type of technique in statistic descriptive. So there are 3 of them. So as a summary, we're gonna have number 1, symmetrical, number 2, skew to the left, and number 3, the data is skewed to the right. Okay, so this is the dot plot, and but it should be a dot, but I don't put a dot over here. I just put an X to represent an observation. So I'm gonna coming back to the slide. So it is another example of dot plots, and as you can see, so we have several observations here. We have many of them, and this is the dot plot, and you can see from the slide that they are using the dot, but because of the limitation of the application that I use, I just put X when I give you the first example of how to make a dot plot. I think this is it. Thank you very much.